Well, hello and greetings from Northern Michigan. This is Bob the Science Guy from Flat Earth Can't Science with my first challenge to the Flat Earth scientific community. Now, if you look below, you'll see the link to Flat Earth Can't Science Episode 4, Phuket Word Gets Lost. In that episode, I showed conclusively how a sextant will not work with a fixed position local Polaris and given accurate latitude. But what about the dome and refraction and refractive indexes of the dome, etc., bending the light from Polaris to the correct angle to read off the latitude on a sextant? Well, that's just fine and dandy. Obviously, we could have some refraction from a dome, and that refraction could indeed bend the light from Polaris to the correct angle for the sextant. Not a problem. Describe how the dome would have to be shaped in order to do this, and then you can use it. So let's clarify a few things. On a globe Earth, also known as reality, when you read the angle to Polaris from the horizon, you get your degree of latitude. On a flat Earth, with Polaris being small and local, you can directly calculate the angle it will appear above the horizon based on the distance from the pole. Unfortunately, this raw distance has no relationship to the actual degree of latitude as it does in the real world with a sextant. Now, I've calculated this difference on a spreadsheet, and you can find the link to that in the description, by degree of latitude from the North Pole at 90 north all the way down to the equator. Now, the height of the North Star Polaris is determined by looking at the angle at 45 degrees north latitude, which is 45 degrees, and then taking the distance from that degree of latitude to the North Pole. That has to equal the height of Polaris on a flat Earth. Using that height, which is 3,112.3 miles, I calculated the angle of Polaris at every degree of latitude from 90 degrees north all the way down to the equator. In order to have the angle of Polaris match the actual degree of latitude, this is the graph of the refractive index by degree of latitude all the way from the North Pole to the equator. Now, since these do not match up to the actual degree of latitude, there has to be some form of refraction going on through the firmament or the dome. You tell me what that's going to be. What shape does the firmament have to be in order to correct these angles and give us proper sextant readings? I've even been so kind as to give you the equations you need to have in order to calculate the size and shape of the lens. So basically the challenge is very simple. You either show me how the firmament does this and corrects these refractive indexes by angle of degree, or you can't get to use it as an excuse as to why a sextant actually works on a flat Earth. So here's a little lesson in science. If you're going to make a proposal, such as, well, the firmament corrects this angle so that everything works out right, you have to actually show how it would do that. If you can't show how it would do that, you're just talking out of your tail end, and you don't get to use it as an excuse or an argument. So here's your chance. Show me how it would work, and I'll let you use it as an argument as to why a sextant actually works on the world. If you can't show me how it'll work by showing me what the lens would have to look like, you simply don't get to use the argument. So have at it.